Hello everyone, I'm Chris. I'm here to bring you a brand new YouTube channel. My goal is to share my experience about computing algorithm. The most important thing is to entertain you via discussion and thinking. Even though you don't need algorithm for job interview or degree, trust me, you will still have so much fun by solving problems, just like playing PC game. Okay, so I hope you enjoyed my introduction and let's begin. Okay, now let's begin today's topic. Today I would like to talk about dynamic programming. Dynamic programming, or DP, is basically a way we think about solving algorithm problems. The way we think is we can split a problem to sub-problems, and then for sub-problems, we will get sub-solutions. So basically, when we try to solve a problem, we will use the already found sub-solution. Okay, I think the concept is a bit complicated. Oh, so let me show you an example to help you understand. Okay, here we have an example question. We have cash note, £1, £2, and £5, and we would like to add cash together to get £7. And we would like to try different combination which contains the least number of cash notes to achieve the number. For the same cash note, say £2, if we want to achieve £4, we allow you to have two £2. And now that's the question, quite easy to understand. But how do we resolve it? To be honest, it's quite difficult to me. And there's a way to think about this question. Is whenever we want to add number to achieve a certain number, there's always a final step. Say we want to achieve £7. That definitely means we did a final step to get 7. And the final step is only one of the three choices. It's either we already got £6 and then we add £1, or we got £5 and we add a £2, or we already get £2 and we add a £5 as the final step. So that's the basic idea to resolve the question. And now here I list the scenario of each sub-question. Say you want to get £0. Clearly the best choice is you have 0 cash notes. And now question become complicated. Say you want to get £1. How would you do that? You have pretty much only one choice anyway. It's you already arrived the previous state, which is 0. And then the final step would be £1, right? That's quite simple. And now, when we arrive to, situation become complicated. We have multiple choice because the final step could be 2. Either we final step at £1 or £1. So now the question we got multiple choice. It's either we take the minimum cash note count for 1 as the sum and add one more 1, or we check the previous state as 0 and we add a 1, 2 count 2 pounds. Okay, and now when we want to solve the question of 3, say how many least number of cash notes we can get 3, then situation is interesting. We can use the previous problem solutions. That's very cool. So still, we try to take the final step. We got 2 choice, either 1 or 2, because if we want to take 5, it's impossible. Because 3 minus 5 is how many? It's minus 2, right? So you got previous state. It's the minimum count of 2 or the minimum count of 1. Then situation is clear. We can just calculate the sub question one by one until we achieve the final goal is 7. We always use the previous solution for the current question. And now we finally arrive 7. Look at that. What's our choice? It's either 1 or 2 or 5. So when we take 1 pound as final step, we got 6 minimum, which the solution we got already in previous step. Or when we take 2 pound, we will take the previous step is 5. Or when we take the final one as 5, then you need the minimum cash count of 2. We got the solution already in previous step. So step by step, we solved this question. That's very nice. Each time when we calculate a question, sub-question, we already have the previous sub-solution. So we are calculating the solution very quickly because we always remember the outcome from our previous hard working. Okay, so go to the pseudocode. It's you got an array. The array is length. The array have a length of 8. The first one is 0, and we already got the answer for that state. It's 0. And we assign a very big number for other state. Now you got a solution for that. Okay. Now the pseudocode is very straightforward. We try to solve the sub-question from 1 to 7, and for each sub-question, we do the 3 try. You know what I mean? If we try 1, 2, or 5 pound. For each one choice, you are thinking that as a final step. That's say 1 cash note or say 1 coin, right? And as long as you can find a previous state, and that state plus the cash value could achieve the number of I, then you can make a decision, right? So if the previous state plus 1 cash note is less than your current best solution, then you can just update that. So in this case, you can see for each sub-question, you try 3 choice, and after that, you will get the best solution of that sub-question. Then you go to next sub question. So finally, we take approximately 7 multiply 3 step. Finally, you update your array, which contains the best, say the minimum count of all the sub-question. And now, the answer of our question is just the value in the number 7 array value, right? Okay, I hope you already got basic understanding about dynamic programming. Clearly, this methodology could be implemented much more complicated to solve very difficult questions. My goal today is just to help you quickly enjoy the fun of thinking in a different way. Hope you enjoy it. This sample question is made based on Topcoder community document. If you want to read more information, you can go to their website. How do you feel this video? Please let me know through comments. I'm also learning a lot and having so much fun by preparing this video. Thanks for watching and see you next time.